Alright, solving triangles. So to solve a triangle, you are able to identify the lengths of all of the sides and the measure of all of the angles. So we are going to use our shortcuts to solve for some triangles, and then we're going to use some other things to solve for triangles as we continue. So when I tell you to solve for a triangle, you need to be able to give me all three angles and all three side lengths. So let's do an example. If I gave you this triangle right here, where you have A, B, and C is the triangle. Now, the lowercase letters are there on purpose. The little b is always across from your capital letter. What you're going to see from now on is the triangles are named with capital letters, and lowercase letters are for the opposite side lengths. So we've got capital letter A is your angle, and directly across from capital letter A is lowercase a, and that represents your side length. So the reason the Pythagorean theorem is always in lowercase a, b, and c is because of the side lengths always being represented by lowercase letters. But if we're given this triangle with a hypotenuse length of 10 square roots of 2, and they tell us the two legs are congruent, we know in this case that we can use the shortcut for 45, 45, 90, and that would mean that A and B both equal each other. I would have to divide by square root of 2 to get from the hypotenuse to my leg, and I know that A and B both would equal 10. So I would already, if 45, 45, 90, by identifying it, I know both of the, all three of the angles of 45, a 45, and a 90. I'm already given the hypotenuse, and I'm provided with A and B. So all 6 pieces of information are accounted for. Alright, so sometimes the triangle is kind of hidden in the problem. So an example like find the length of the diagonal of the rectangle, and it gives you a side length of 3 centimeters, and it gives you an angle measure of 30 degrees. Well, since the diagonal cuts the rectangle into two 30, 60, 90 triangles, you can use the shortcut. So I know this is a 30, 60, 90 because of that 30 and because of that 90. So I know that 3 centimeters would be the short leg. It's across from the 30 degrees. So to get from short leg to the hypotenuse, I would just multiply by 2. The diagonal is 6 centimeters long. Another example, the length of a diagonal in a square is 20 inches. What is the perimeter of the square? So the first thing you're going to want to do is draw a picture. A square has congruent sides, so I know I'm working with a 45, 45, 90. I'm going to go ahead and draw just the triangle and label the hypotenuse as 20 because the hypotenuse is represented by the diagonal. I know to get to the length of a leg, I want to divide by the square root of 2. So literally 20 divided by square root of 2, you can use your calculator to come up with the answer, or you have to remember to rationalize your denominator. What that means is that you do not want a radical on the bottom. So I'm going to multiply the whole thing by radical 2 divided by radical 2. Anything over itself equals 1. This is just how I'm representing the number 1 so that I can get the radical out of the bottom. You multiply two fractions by multiplying straight across. So 20 square root 2, and then square root 2 times square root 2 is the square root of 4, which is just 2. So I've got 20 square root of 2 over 2. The 2 divides into the 20, and it rationalizes to 10 square roots of 2. So I know that 10 square roots of 2 is the length of one of the sides, but that's not what the original question asked. It wants to know the perimeter. So I would multiply that times 4, or add it up 4 times, and I would get 40 square roots of 2 is the perimeter of the square. And last but not least, the side of an equilateral triangle is 18 inches long. What is the height of the triangle? This particular problem actually illustrates where a 30, 60, 90 triangle came from. But in an equilateral triangle, after I draw my picture, I remember that an equilateral triangle, all 3 angles are 60 degrees. It is equilateral, so all 3 sides equal 18 inches. By drawing that line straight down the middle representing the height, I'm cutting this angle in half, so the 60 gets cut into 2 equal pieces, so it becomes 30 and 30. So now I have a 30, 60, 90. And I'm also cutting the sides in half. So instead of being 18 inches long, this portion of it is just 9 inches long. So that's why you always have to divide by 2 to get to the short leg. Alright, so the line that represents the height that creates the 30, 60, 90 triangle. So I know again that's cut the whole equilateral triangle in half, making this 9. And then in order to get from the short side to the altitude or the height of the triangle, I would multiply by square root of 3. If you couldn't remember what to do at this point, you would have the hypotenuse and the short side, and you could use the Pythagorean theorem to figure it out. But we find that the height of the triangle is 9 square roots of 3. So this is kind of the harder version of some of the problems that might use 30, 60, 90s. Be prepared for a quiz on Wednesday. Thanks.